Our first topic is the basic principle, concepts, and definitions of thermodynamics. Thermodynamics is that branch of physical science that treats various phenomena of energy and related properties of matter, especially of the laws of transformation of heat into other forms of energy and vice versa. So we see thermodynamics, it also deals with the energy related concepts within a matter, like mechanical energy, chemical energy, heat energy, and other kinds of energy on a matter. As I said a while ago, as I said way back then on a first orientation to the thermodynamics, that the thermodynamics one is a basic or it's the foundation of all higher mechanical engineering subjects like power plant engineering, HVAC, industrial plant engineering, and other kinds of major subject in mechanical engineering. Its intended learning outcome would be identify the different properties of pure substance, ideal gas, and real gas, apply thermodynamic concepts and principles in analyzing and solving problems, apply the laws of thermodynamics in analyzing problems, and evaluate the performance of thermodynamic cycles. But here in Module 1, we are only going to apply the ILO1 and the ILO2. Next, thermodynamic system modes of heat transfer. Heat energy can be transferred from one body to the other or from one location in the body to the other. Study of the techniques and the methods adopted to transfer heat energy is known as heat transfer. To facilitate heat transfer between two bodies must be a two different temperature, one higher than the other to allow heat to flow from one body to other. This means that no heat transfer occurs between two bodies which are at the same temperature. At the same time, it's very important to note that the heat only flows a body at a higher temperature to a body at a lower temperature. Although this may look obvious, this law is very important from the point of view of thermodynamics. Now, we should take note with this paragraph, with this sentence. At the same time, it is very important to note that heat only flows a body at a higher temperature to a body at a lower temperature. So that means heat transfer is from higher to lower. Common misconception for us is that when we are in an air-conditioned space and the door is open, while they open, we say that the the cold will go outside. Well, in fact, the heat will go inside. Next, there are heat transfer takes place in one place of the three ways, namely conduction, convection, and radiation. There are three modes of heat transfer. One is conduction. Conduction is the method of heat transfer of heat within a body or from one body to the other due to the transfer of heat molecules vibrating at their mean positions. Now, when you say conduction, it's very familiar to you. It's very known that conduction takes place when a direct contact, when there is a direct contact from a heating medium to the heating surface. Let's say, for example, a flame that is heated, a flame, we have a flame and a pot, and the pot is heated by the flame. The flame is our heating medium, and the pot is our heating object. It's the heated object. Convection is the mode of heat transfer which occurs mostly in the liquids and gases. In this method, heat transfer takes place with the actual motion of matter on one place within the body to the other. Often when we boil water, we have seen bubbles and currents develop in the water and on careful observation. Another good example for this convection is a boiling of water. When boiling of water, there is two modes of heat transfer there. First mode is conduction, where the flame directly contact with the pot and the pot is heated through the flame. That is a conduction. Whereas the boiling of water is in direct contact with the flame. using a medium that is fat. So when we say convection, indirect contact from one body to another, the fluid. Convection takes place between the pot and the water. Conduction takes place between the flame and the pot. Radiation is another form of heat transfer. It does not require any medium and can be used for transfer of heat in a vacuum as well. This method uses electromagnetic waves which transfer heat from one place to another. The heat and light from the sun is in our solar system, reach our planet using radiation only. Now, this is the best example of radiation modes of heat, mode of heat transfer. The radiation through the sun, which reach to the Earth or to the Earth surface. Now, systems of units. Systems of units, according to Newton's law states that the acceleration of a particular body is directly proportional to the resultant force acting on it and inversely proportional to its mass. Let's say, for example, this formula comes from the mother equation, force equals ma. But since force equals ma, there is a uh, there is a unit that is hidden. That if we multiply the mass by its acceleration, we cannot yield the force. So with the help of proportionality constant k, we we justify the formula force equals mass times air, force times acceleration. System of units where k is unity but not dimensionless. In CGS system, one dyne of force accelerates 1 grams of mass at 1 centimeter per second squared. In metric system, 1 Newton force accelerates 1 kilogram of mass at 1 meter per second squared. In English system, 1 pound force accelerates 1 slug mass at 1 foot per second squared. We should take note or we should remember these values and these unit and this unit. System of units where k is not unity. If the same word is used for both mass and force in given system, k is neither unity nor dimensionless. Let's say, for example, when it's used as mass, 1 pound force accelerates 1 pound mass at 32.174 foot per second squared, while in 1 gram force accelerates 1 gram of mass at 980.66 centimeter per second squared, and 1 kilogram force accelerates a 1 kilogram mass at 9.8066 meter per second squared. Now, these values is at standard condition. There are, why did I say that? Because there are some problems that is stated that that problem is at standard condition, that a certain objects at standard condition. So when we say that at standard condition, we should we should remember, we should know that standard condition, this gravity or this value should be used when in terms in English system or in metric system. Relation between kilogram force and Newton. Now, this formula is we visualize or we present the relation between the kilogram force and the Newton. Well, in kilogram, 1 kilogram mass meter per Newton second squared and 9.81 kilogram mass meter per kilogram force second squared. We equate it since we are going to have the relation. What is the relation between each other? And it yields that 1 kilogram force is equals to 9.8066 Newton. And it is the same as the relation between pound mass and slug. The difference is its unit. Therefore, 1 slug equals 32.174 pound mass. In acceleration, acceleration is a unit of force is one that produces unit acceleration in a body of unit mass. Like what I said earlier, force equals mass times acceleration. in terms of acceleration, where in terms of weight, force equals mass times gravity. So here in acceleration, we also use proportionality constant, K, for us to easily cancel out all unnecessary units for us to yield the correct unit for our solution, for our answers. Now, in terms of mass and weight, the mass of a body is the absolute quantity of material in it. The weight of the body means that the force of gravity Fg on the body is here. Mass over K equals F over A equals Fg over G. When in terms of mass and weight, just like what I said, it comes from a mother equation only of force equals mg. Force equals ma for the acceleration. Uh-huh. Now, let's go to problem number 1. Problem exercise number 1. The problem number 1 states that what's the weight of a 66-pound man at the standard condition? At standard condition, we say that what is the weight of a man at standard condition? Just like what I said earlier, when the problem stated that it is at standard condition, we should know the values of gravity, or we should know the values of a standard condition for that kind of system. Like for example, since it is 66 kilogram mass, kilogram is a metric system, we should know the value of gravity at standard condition in metric system. So therefore, the value of gravity in metric system is 9.81 kilogram per second squared. Meter per second squared, sorry. 9.81 meter per second squared. We will be going to use 9.81 meter per second squared and 32.2 foot per second squared for us to have a uniform answer. Now, since our mother equation is force equals mass times gravity over its proportionality constant K. Take note that we should never forget to use or to indicate the proportionality constant K because we cannot cancel, we cannot analyze its unit if we don't have this proportionality constant K. So our M would be 66 kilogram mass times its gravity 9.81 will be using meter per second squared over what is the proportionality constant in metric system? 9.81 kilogram mass meter per kilogram force second squared. So here is our, so what is the use of proportionally constant K? This is the use. We cancelled out S squared, second squared rather. We cancelled out meter. We cancelled out kilogram mass, kilogram mass. All we have left is kilogram force. So therefore, when we compute 66 times 9.81 divided by 9.81 is 66 kilogram force. Now, take note of the unit. The problem asks what is the weight of a 66 kilogram mass man at standard condition. So, our answer is 66 kilogram force. So, as you can see, kilogram mass is different to kilogram force because when you say kilogram force, a gravity must be acted upon it. Okay? So, that is the use of proportionality constant K for us to have a clearer unit analysis. Okay, let's go to problem number 2. I will going to erase it first. Okay. Problem number 2. Problem number 2. The weight of an object is 50 pounds. What is its mass at standard condition? Uh, the, uh, the, the, the problem is asking what is its mass at standard condition. So from our mother equation, force equals MA, mg, over its proportionality constant K. The problem asks what is its mass at standard condition. So we are going to find what is the mass. So we need to derive the equation where mass equals force multiplied by its proportionality constant K over its gravity. See to it that the problem is at standard condition. Therefore, we use a gravity at standard condition. Since it is pound and it is an English system, so we should use an gravity on standard condition at English system. The gravity at English system is 32.2 pound, 32.2 feet per second squared. So we substitute the values. The force, 50 pound. One tip that I'll be revealing to you is the word weight. When we say weight, it is the force. It is a force. So when you say the weight of an object is 50 pounds, it is a force. It is F, not M. Don't confuse with that too. Okay? 50 pounds times its proportionality constant K, 32.2 pound mass, feet per pound force second squared. Again, I'm sorry for my handwriting. It's very hard for me to write here in computer because I'm only using mouse as my medium of handwriting. Over its gravity is 32.2 feet per second square. So the effect of proportionality constant K is to eliminate unnecessary units. S squared, we cancel S squared, we cancel feet, we cancel pound mass. Sorry, I'm sorry for that. We cancel pound force. And all we have left is pound mass. So when we compute 50 times 32.2 divided by 32.2 is equal to 50 pound mass. So that is our answer. So as you can see, 50-pound mass is different to 50-pound force. Why? In because it's A in terms of mass. It's unit. This is mass without its gravity, while this one force is acted upon with gravity. That is the difference between a pound force and a pound mass. And at these two problems, we can also conclude that the proportionality constant K is very much important for the entire equation, since this proportionality constant K serves as our guide for unit analysis. More sample problems will be discussed uh,